take all of that out and we can then delete that. Okay. Okay. Here. And there you go. Right, so now we're roughly in the right place. We're going to name this tile instead. And it's going to be made up of tiles. Tiles are going to be different to sprites. We use basically the same code to begin with. For now, we're pretty much going to use the same code anyway. When I say pretty much, I mean we're going to use the exact same code to do everything in it. I've just actually got a note. I've got to remember to just change that just a tile, and it's no different. Exactly the same code. Okay, and this dot, just change that instead to tiles instead of sprites. Just set this up. The only difference we're going to do here, you'll see in a moment. And here we're going to remove tile instead. So that's going to load that. The only other thing we're going to load is a new private image. New private image called ref. And we'll put the thing up there. Here, what we're going to do is we're going to do ref equals new image, and we'll make that f name ref. Need some camera here. Okay. So our function down here now, everything's the same. Everything's pretty much the same. It's just going to create a new, pretty much the same as a sprite sheet. Just we called it tiles instead. Except in here, what we're going to do is we're going to create a new function of tiles, a new loop, sorry, of tiles.size, and instead it's going to send us ref instead of I. We'll check just to make sure that it's still in the right size before we start the loop. Obviously, otherwise we'll be wasting time. Sorry. And so what we're now going to do, in here, we're going to do int color, and this is going to be this dot ref dot get RGB. Now, for here, we're going to, we've got to get rid of it, we're going to give it an X value and a Y value. So X equals I over this dot ref dot get width. No, sorry, that's going to be modulus. You're going to use percentage. Now what this does, in case you don't know, in case people watching don't know, the modulus, the percentage sign here, says if we divide I by the width of the reference image, what would be our remainder? And so, for example, if I is 6, our X value, we know ours is only 5 wide, so it means we'll be on the second row and we'll be on the first tile, will be the one we want. So I equals 6. No, sorry, it'll be the second one in, not the first one. I equals 6. When we divide it by 5, we get a remainder of 1. And obviously we're counting from 0, we got 0 and then 1. So it'll be our second one. And Y does I, which is 6 divided by 5, which returns 1, and we ignore anything else in the division on this because it turns it into an integer. And that's why we can then do that. And here we'll make new int from X and Y. Okay. In here we then want to find out the red, green, blue value for X and Y for colour. And let's add colour outside. Actually, let's add a W and then add a colour. Where W equals this dot get width. This way, rather than having that every time it always searches up, it only does it once and then just uses the number it remembers. And we'll delete that as well. We're going to have to add this function in. We're just going to quickly test if X is less than 0 or X is greater than or equal to this dot width, or Y is less than 0 or y is greater than or equal to this dot height. We're going to return -1, and this will just tell it that it's foul, it hasn't managed to do it. Otherwise it's going to return this dot pixels x plus y times this dot width. So this will then return the colour that is at the pixel we selected, and this is using our reference picture, and this will tell us which. Okay, and then what we're going to do is if this dot, if colour equals ref, and we have to use two equals because it's saying if it's equal to rather than it is equal to, if that makes sense. So if colour equals reference, basically reference is going to be a colour you're sending it. So on the map, each pixel is going to represent a tile. So there's going to be a green pixel, and that represent grass. So using our reference image, we find where the same green is. Once we've found them, which is the colour is equal to the ref, that means we've got the right one. And for this, we can return this dot tiles dot get I. And if it doesn't happen, so if it goes through the whole loop and doesn't find any, we'll return null, like that. What we should now be able to do in game is delete our sprite sheet because we won't need that anymore. Here we're going to do ts.getSprite, and I need to find out one of the colours. Let's just quickly open. So this is our textures file. If I quickly open the reference file as well, which is this one here. So you've seen that, like on the map, something can represent this. So if we take this green, for example, we can take this code here. When we come into here, we can do 0 times FF. This just means it's not transparent. So the FF just means the alpha. And we're not getting sprite, we're getting tile instead. And so what this should do is just using that colour, it should now return the grass. No, it doesn't. No, 1% time. Okay. We instead make a new tile for width T, and then do this. So now what we can do is we're going to store the tile before we do it, and this allows us to, if T does not equal null, and this will stop it failing as it did a minute ago with a null point acceptor. So now T will start to render if it doesn't equal null. So if we stop here and rerun, you'll see that it doesn't render. I'm just going to leave that to start off the screen while I try and work out why. So in our tile sheet, we need to go into here, system.out.println and ref. So we're trying to print the reference out. Okay, it's not even come this far in. Okay, that's because we're testing to see if it's correct. Less than 0 and all the colours are less than 0. Okay, you see over here now, the grass is printing. That was why we weren't testing properly. We were trying to test to see if it was on the screen, and anyway. Okay, so now you can see we can print that, and if I used a different colour, so if I use this colour instead, for example, the orange, and put that in there, you'll see now it prints our lava texture instead. This is going to be a lava texture. Now that that's working, what we can do is we can start to make a map. So we're going to make a public map. And all we're going to include for the map is just the name, the file name for it. So map1.png in this case. If I quickly show you the map file, if I go in here, so this is our map file. As you can see, all the different coloured pixels all represent one of these on here, and it should print the map perfectly when we get into it. Okay, so now we're just going to create a class called map in world, and I'm going to move the tile sheet yeah, and the other thing I'll send it is TS, which is our tile sheet, and just this way the new maps can use different tile sheets, and that way I don't have to have every tile sheet loaded, or every tile loaded, sorry, for different maps. So if I go into an icy map, I can ignore the one that I've got loaded at the minute that includes all the lava and the rock and stuff like that, and make it more ice and snow. So that'd be something new to do as well. Okay, what I'm going to do for this is I'm going to make a new image. And this is just because our image class contains a way to load images this way. And okay, so we just create a field of that and input that as well. So next thing I'm going to do is create a new loop. I need to know the width and the height, so I is less than